Okay, here's another example. This is a more complicated circuit. I just want to know what is the equivalent capacitance of this circuit. Um, the first thing on this was made more complicated because the circuit is laid out in a different fashion than what we've seen. So the first thing that we want to do is just redraw this in a more standard fashion. So if you ever look at circuit diagrams, like on some of your electronic devices that you might get in the user's manual, you'll see that the circuit diagrams do not look anything like the circuit diagrams that we're drawing. They look more like this, where they're sort of laid out on this grid-like fashion. So let's see here. The way I want to do this is I want to come along here, and I want to look for the parallel branches. So I mark the beginning of a parallel branch right there. And then if I follow along here, I mark the beginning of a new parallel branch right there. All right. Likewise, here, I notice that this parallel branch comes back together here. In fact, I can reimagine this as having these two connected, and then they connect to that wire right there. I'll redraw this in just seconds to help you understand this a bit more. And then this comes back and comes back to the battery. So let's try redrawing this first of all. I have my 12-volt battery. I have my 6 microfarad capacitor. And then it's going to come up here and it's going to split into 2 branches, there and there. So this corresponds to the red dot here, these 2 branches right here. Now in the first branch, I get my 4 microfarad capacitor. All right. But then that branch splits again into a 2 and a 2. All right, so this dot right here represents here, and then that comes back together. All right, so over here somewhere. And then this capacitor, my 1 microfarad, and then it all comes back together right here and goes back to the battery. So this comes out, they come together, and they come back to the battery. All right. Now this is more akin to the example that we worked before, all right, but it's laid out in a different way. So you should be able to take a circuit like this and be able to figure out which of the components are in parallel and which are in series, and be able to redraw it, or at least to interpret it to find the equivalent capacitance. All right, so let's take the smallest branch first. That is going to be here. I have two 2 microfarad capacitors, and if you recall, the combination of those, well, actually, no, for a parallel, I just say 2 plus 2. So the equivalent of this is 2 plus 2 equals 4. I'm going to redraw this whole circuit now. You don't have to do this, but I find that it's helpful when you first starting playing with these circuits. This helps you to visualize them a little bit better. See how now I have a 4 and a 4. Along with a 1. And then that comes back to the battery. As you get better and better at this with more and more practice, you'll be able to just look at this and be able to tell what this is. Like I can look at this and I can say, well, this is 2, 2 and 1 is 3, and then a 3 and 6 in series is 2. So I often use really simple numbers. So you'll see there aren't that many sets of simple numbers that you can add inverses of, but I tend to use those to help you in the math. So let's go through here. I have 4 and a 4. Those are in series, so I say 1 over 4 plus 1 over 4. That's equal to 2. So I can replace those 2 capacitors with a 2 microfarad capacitor. Let's redraw this again. Again, you're not really going to be able to redraw it each time on a test because of time, but it's useful when you're just practicing in the homework or whatever. Now I have a 6, a 2, and a 1. I can combine this 2 and a 1. 2 plus 1 equals 3. And then I'm just left with a 6 and a 3 microfarad capacitor. I say 1 over 6 plus 1 over 3. All right, 1 over 3 is the same as 2 over 6. So that's 1 over 3/6, or 1 over a half, which is equal to 2 microfarads. And that's my final answer. That's the 2 microfarad is the equivalent capacitance. Now, there are a number of different things that you could do with this. Like, for example, I have a 12-volt battery. What if I want to know the voltage on this? All right. Well, I could say I know that the equivalent capacitance is 2 microfarads. So the equivalent charge is going to be C equivalent times V. That's going to be 2 times 12, or 24 microcoulombs. So I know that there are 24 microcoulombs on this capacitor. And since there are 24 microcoulombs, that's going to be Q over C for my voltage, 24 over 6, or 4 volts. All right? Because of that, I have 4 volts there. I know that I have to have 8 volts here because I have a total of 12, and 12 minus 4 is 8. And if I have 8 volts there, that means I have to have 8 volts on both of these. All right? So I have 8 volts on this capacitor. I have 4 volts on this capacitor. And look, these two capacitors are identical. That means that they split their 8 volts identically. All right? So I'm going to have 4 volts on this capacitor and 4 volts on this capacitor. These are our 4 microfarad capacitors. All right? And then further from that, if I have 4 volts there, that means I have 4 volts here and 4 volts here. All right, so now you have enough information to find either the charge or the voltage on any one of these capacitors. That's why it's really useful, actually, when you're solving these problems, to write out the circuits. If you're trying to find the charge or the voltage on each capacitor, it's nice to be able to follow the changes that you've made as you go along the way. Let's take a quick look at these quick tests. Here's a simple circuit, but it's a combination circuit. You can see something as simple as this on the test. In fact, this was an old test question. So we want to know the charge on this capacitor. So our first step will be to find the voltage on that capacitor. To find the charge on that capacitor. I'll leave you there, but you want to find the equivalent capacitance of this, and then you'll know what the voltage is across that, and you can find the charge on it. I think there was another one. Okay, yeah, here's another one, the equivalent capacitance of this circuit as well. And as I said, there are a number of different questions on the old test. Oh, and so here's also a great question about what is the potential. And you can find a number of different questions on the old test for these as well. They're good practice. You'll see, 3 to 5 questions that are just capacitor circuits on the next exam, very likely. All right, we'll pause there and we'll move on to energy next.